Okay, hello. How are you guys? Back in school? Who just came in hot from break? Like you just got here? Anybody? Yeah? Where'd you come from? Home? That's cool. I was in Florida like 48 hours ago, so now I'm just like, Well, so hi, so my name is Brandon, Dr. Brandon Pico. You guys call me Dr. Pico if you want. I am a professor here in biology, and I know some of you, others of you I don't know, which I'm excited to get to know you. So I'm a professor here in biology. I'm also the curator of paleontology down at the Idaho Museum of Natural History. So has anybody been to the museum you all have on campus? Yes, some of you work there, so that's good. So that's a pretty awesome resource that you guys have as Bengals, and if you haven't been yet, I'd really like you to go. It's free with your ID, so bring people and have fun. This is a really, really fun class. So I consider myself like an organismal biology kind of person. I care about how organisms work, how they function, how morphology features into that. And a lot of times classes like this in the past have been taught with like a really heavy like memorization and dissection component. Like you guys are gonna learn all these shark muscles and all these shark nerves, and you're gonna learn all these cat muscles and all these cat nerves. And we're gonna be like, check it out, they're the same, except the cat's got 6 other things going on. We're not gonna really do that because I've never liked that very much. I hate it, to be honest with you. So we will have dissections and stuff in lab. I'm not gonna talk about lab today, so that's 3314L. I think you're all registered for it. And if you're not, you need to be. Because of the holidays, we're not meeting in lab until like 2 weeks from now. So we have got like a pretty late start for lab. But I did manage to get together a bunch of pretty cool weirdo animals for us to dissect. So you guys are gonna get to mess around with like stingrays and snakes and cool stuff like that. It won't just be a shark and I don't even think we have any cats anymore because nobody likes dissecting cats. I think it's all bunnies and minks. But even that, we're not really doing that. I even got a couple turtles, which I've never done that before, and I don't know how you like, unless you have a hammer, I don't know how you dissect a turtle. But I'm excited to learn. I'll be learning with you guys when it comes to that part. So I'm a paleontologist, which means I study fossils, and fossils are the remains of ancient life. A footprint, which is just a hole in the mud, is a fossil. But a lot of times when you guys think of fossils, you're probably thinking of bones and shells and wood, which are the hard parts of organisms that preserve. So my whole like professional deal is like just the skeleton. And so I have learned a lot about brains and about kidneys and about breathing and about muscles, and you guys will too in this class. But rather than like kind of have this be very heavy duty memorization, I really think that most students walk out of classes like this with a richer college experience, and what I care about the most, you're more likely to like remember it into your life future instead of forgetting it the second the exam is over. If we kind of talk about big picture stuff and narratives. And so as a paleontologist, I care a lot about the evolution of life on Earth and history of life on Earth. And guess what? Comparative vertebrate anatomy is like where we could see so much of that happen. How do I know Tyrannosaurus Rex and a hummingbird are close relatives to each other, closer than either one of them is to like Triceratops? It's comparative vertebrate anatomy. I mean, we call it paleontology, but what everyone's doing is comparing the anatomy of some vertebrates in order to do that. So I'm really excited to get into this with you guys. We'll walk through the course here and what the structure is going to be as we go through. But I need to just say this out loud at the beginning so that you guys will yell at me if I mess up. This is about living organisms. So there are a couple times when I'm going to touch on fossils because I cannot help myself, but this is a class that's going to be focused on the living biodiversity of the planet. Animals that if you guys got some binoculars or some scuba gear, you could go see tomorrow if you wanted to go and find them. So does anybody know what this animal is? You don't have to yell it out, but just curious. Anybody have no idea what this is? Okay, now I'll ask if anybody actually knows what it is.
Is it a quetzal?
Ooh, a quetzal. A quetzal. So quetzal is a nice, a bird that only eats avocados. That's not totally true, but they do have a seed dispersal relationship with wild avocados, which are only about this big. That is not a quetzal, although it is a Central and South American bird, which quetzal is also our Central and South American bird. That's a bird that's all by itself in its own order. So you guys remember, probably from high school or something, like terrible kingdom, phylum, family, class, genus, all that kind of stuff. So orders are kind of a big level of organization. They don't really mean much anymore. We're going to talk about that. This bird is all by itself in its own order. There's no other species. There's one species in its order. There's only a couple of mammals like that. Aardvarks are all by themselves in their own order. And this bird, which is called the hoatzin. So the hoatzin is a big South American bird. I think it's up into Central America, I think, but it might just be a Central American or South American bird. It has a million features that you guys right now, none of you thought that was a snake. None of you thought that was a shark, right? You all knew immediately that it was a bird. And there's a bunch of things that you picked up on to know that are anatomical. But it also has a bunch of very specific to it adaptations. This is a bird that is specialized in eating leaves. It eats leaves for its diet, not fruits and nuts, not little bugs. It eats leaves. So there's a bunch of adaptations it has to do that. Most birds don't eat leaves. You need a big fat gut to eat leaves because they're really nutrient poor for how much you have to eat. So it's a big bird. Also, this bird is very famous in evolutionary biology because many of you probably know birds are living dinosaurs. They are a member of the dinosaur family tree. So a penguin and a chicken nugget, they're all dinosaurs. But the Hoatzin is very, very, very cool. Through a little trick of developmental biology, chicks, baby Hoatzin, are the only birds that live now that when they hatch, they have the claws on their fingers and they use them to climb around. So you can read awesome scientists, looking at stuff, and indigenous peoples in South America knew this. This bird has like fingers that you recognize, but then they go away and the adults don't have claws anymore. And it looks just like a normal, what you guys think is a normal bird. And so the anatomy through the growth series, through the ontogeny, which is what we call it through an animal's life cycle, the ontogeny of this bird shows us like a reversal in evolution, which is really, really fun. And it's an adaptation for their environment. These babies live in swampy water. If they fall into the water, like there's crocodiles and things like that. So they just climb. You guys have seen baby birds, right? They're not sometimes very clumsy and naked, and these ones climb around. It's very weird. But it's a great animal to have as our little mascot. We'll come back to the Hoatzin later. I wanted to give you guys a little bit of information, there we go, about me. I've met some of you before, but like I said, most of you I've never met before, so hello again. This is a map, I think you know what it is. I like to show maps like this, and if you've been in a class with me before, you've seen this map because I really like showing you guys things that you definitely already know about, but like hopefully in a way you haven't seen. So one thing that really bothers me is like when we had that cold snap in December and the whole country went cold, everybody's like, oh man, this is freezing, this is the worst. And all you gotta do is like hit the like minus to zoom out, and you see that Europe's getting really hot while we're getting really cold, and all these things are connected. So there's no lines that monkey people made up on this. This is just what the continent looks like. And I hope you guys can take it and see some things you maybe didn't notice. The Bahamas really do look great from space, don't they? I'm glad to see you guys, don't worry. Okay. So I just want to give you guys my background a little bit. So I grew up in these places in Ohio and Michigan. That's where my whole family is from originally. So that's where I grew up. I went to college at the University of Michigan. So National Football Championship didn't really work out this time, but that's okay. It was close. So I'm a Wolverine, and I worked when I was an undergrad, when I was you guys, from my sophomore to my senior year at the Natural History Museum on campus in Ann Arbor in Michigan. And my major was ecology and evolutionary biology, which is kind of the equivalent of like our organismal and eco smushed together, that kind of thing. When I was an undergrad, I had a really wonderful opportunity to do like a research project and go do research. I did that at the museum in New York City, the American Museum of Natural History. That's like one of the big paleontology museums, but it's also just like a really big natural history museum in general. If you guys watch the Macy's Thanksgiving Day Parade, when they're blowing up all the big balloons, there's a ginormous, pretty pink brick building. That's the building that I was in. So I spent a summer, my undergrad there between my junior and senior years in New York. And that was the first time I ever like was in museum collections and saw drawers of millions of objects and like did research and was like, oh, research is just like messing around and asking questions. And anyway, that's where I learned that kind of thing, got excited about it. So then I decided I wanted to go to grad school. And so I went to grad school in Seattle at the University of Washington. So I don't really care about the Huskies like I care about the Wolverines, but I did go to UW and was there for 6 years to get my PhD. After I got my PhD, I had a job for a few years at the Field Museum, which is a big museum in Chicago. There's a big Tyrannosaurus Rex there named Sue, who's very famous. And finally, just a couple years ago in 2019, like 2 seconds before COVID, like right at the end of 2019, was when I got a job here to work with you guys. And so like I said, I'm a curator at the museum down campus, and then a professor here in biology. And so I was like seeing, and I encourage you guys to do this if you haven't, kind of put yourself on a map of the world. Research-wise, I am a paleontologist, and so I know some of you have seen this before, and I'll stop saying things like that. But this is a map of the world almost 250 million years ago. You know, it's an approximation. We have evidence to let us know this is what the world looked like. And this is kind of like where my brain lives when I'm doing my research. So the Permian period and the Triassic period are the two periods in our history. 250 million years is about the boundary between them. This is when the first mammals evolved, the first turtles, the first dinosaurs, the first crocodiles. This is also the biggest mass extinction event in our history. It happens right between these two periods. And so this is what I study. There's animals and biogeography and evolution from this time period. That weirdo thing up there on the left is a relative of us. It's a mammal relative, believe it or not. And then that thing on the right over there is an early dinosaur cousin. And so my research is usually in the southern part of this thing. What's this thing called? Anybody know? Pac-Man shaped thing. Yeah, Pangea. So Pangea is a thing for like 80 million years, and that's the time period I study. So there wasn't a Pangea, then there was, and then it broke again. So I study life on Pangea for my research, and so I've done most of my work in the southern part of Pangea, so in places like Antarctica, where like right now it's an icy wasteland, but if you go there to the mountains and you hit the rocks with a hammer, you're gonna find leaves and amphibians and little mammals and all kinds of really cool fossils. And obviously you can say, wow, things change on this planet. If the middle of Antarctica is full of a forest with frogs in it, that's not true anymore. And then most of my work, to be honest with you guys, is actually in Africa, so in places like Tanzania and Zambia. So this is me in what's now pretty dry forest in Zambia, digging up fossils of actually an animal just like that one on the top left. And so what I care about is vertebrate anatomy, of course, but also paleontology and evolution from like this time period. That's like personal specific research. And just so you guys know, there's Pocatello 250 million years ago. Idaho is coastal, it's beachy. California and Oregon and Washington don't really exist yet. Technically, that's part of California right there. It's still on its way. Actually, I kind of think it's both. Pangea's going that way and it's going that way. They're gonna hit, but don't worry, it hasn't happened for a long time. But that's where Pocatello is. A lot of you might know that we have like the buzzsaw shark here, the shark with the spiral of teeth. And if you take 2 seconds to be like, wait a minute, why are there shark fossils from Idaho? Why can't I find seashells on Mount Bora? Well, because Idaho used to be underwater / on the beach / never again underwater. And so there's like a thing you can see in Idaho's rocks where ever since the Jurassic, it's been high and dry and still is high and dry. But anyway, that's me. That's who I am. That's where I come from. So like I said, I'm the curator at the museum. Ruth, you're there. There's Ruth like years ago before COVID, like 2 seconds before COVID. I bet that's February of 2020. Showing, and I have shorter hair because it's not COVID times yet. And this is the collections. And so I just said a second ago that you guys should go there if you haven't. I want to really stress to you that you go to college where Idaho's Natural History Museum is. If people find fossils on federal land, like in the Panhandle, it comes to Pocatello. We are the repository for the state. So natural history collections generally, like I said, I do the fossils, but there's pinned bugs and fishes and Native American artifacts and heritage items and meteorites and crystals and all that kind of stuff. It's all here on campus. You guys have access to it in a variety of ways through this class. We will go there. If you haven't gone to the exhibits, go. You also can definitely get involved at the museum. I work at the museum. We hire people at the museum. So if you haven't been, please check it out. I will take you guys later in the semester. So if you haven't been, you can go. But most of you people are probably Idaho people, or at least regionally. Some people are Eastern Oregon, maybe. Some people are Utah, maybe. Okay. So part of my job is to go out and like collect fossils for Idaho. And I always just like to show this because there's a little bit of anatomy here. It's not all vertebrates, just so you guys can have some like Idaho pride. Idaho has a really excellent fossil record, even though like places like Utah, Montana, sorry, have like a much better fossil record, so everyone knows about them. But Idaho's got a great one. There's a fossil I found last summer of a little trilobite. It's one of those little buggy things. It's 508 million year old fossil from down near, kind of just past lava a little bit. You know where that is? There's a nice spiral shell of another sea creature. You can call it ammonite, squid thing. That's from like Soda Springs. If you go around Soda, there's a lot of like Triassic, 250 million year old ocean fossils. They're really easy to find. This site made me laugh because it's just like under a sagebrush, in the middle of the sagebrush. Like there's cows everywhere, and like just under this, like for 40 feet on one of the hills, you break rocks open, you're gonna find seashells. I think that's cool. There's one of I love this one. This is a nice crocodile armor from up near Wayan. So if you guys know up like where Alpine, Wyoming is on the way to the Tetons, there's nice crocodile fossils here in Idaho. Lots of dinosaurs too, which you will end up hearing about that from me. And then some of Idaho's best fossils, and again, I hope you can see how anatomy is important. You usually just find bits and pieces of things when you're a paleontologist. So you got to be like I know what this is. This is me on the beach at American Falls. If you guys have never been out to American Falls, please go out and check it out. If you find any fossils, call in the museum or call the Bureau of Reclamation, which is an office in American Falls. But this is us walking the beach, and right here in the sand, these two gigantic things that are about as big as your tennis shoe. Those are the molars, top molar of a mammoth. So the beaches of American Falls are full of about 100,000-year-old ice age animals, which is really cool. And I just wanted you guys to take a quick second before I stop talking about fossils completely to appreciate that you're surrounded. That buggy thing is 500 million years old, and that elephant is only about 100,000 years old, which I know those both sound big, but they're not the same. And they're all here. They're all around you here in Idaho. So come to the museum, check it out. All right, I've been blabbing for 15 minutes and I'm going to stop now. I have some sheets I'd like you guys to fill out to help me get to know you a little bit, know your neighbors a little bit. Pass them around and I'll grab spares. So we'll take like 5-10 minutes here. You can take your time, we're in no rush. We'll do about another minute or so, see a few people. Okay, most people look like they're getting there. So go ahead and find somebody next to you or somewhere nearby and introduce yourselves to each other. Maybe you know them, maybe you don't, but go ahead and share what's on there and we'll be back together in a second. Groups of 3 work for me.
Well, I always feel it, and it's like, Oh, yeah.
All right, so in a minute here, we're gonna have you guys, you keep talking, but in a minute, we're gonna have you introduce your neighbor, and if you're in a triangle, you're gonna have to do a little one of these actually. But figure that out, we're gonna introduce each other to the class. Okay, you got a minute or something. Just a name, just who they are, you don't have to say anything too fancy. And you only have to say their name, you don't have to say all the stuff on the sheet. Just the name, name is enough. I'll collect the sheets.
You want
All right, do we have any volunteer groups? Yes, Calvin. Oh, I shouldn't have said, sorry. Yes, that guy. Hi, Callie.
This is Diana.
Hi. Who's that? Calvin, there we go, okay. How about you guys?
This is Jaden.
Jaden, hi. Hi, Frania. You guys?
This is Savannah.
Savannah. Oh, now what will happen?
I know. Oh, wait, I'm too.
Wait, okay, go around again. This is also, in case you haven't noticed, this is how I take attendance and find out what you like to be called. That's what we're doing. Okay, go ahead. Savannah. Andy. And Ace. Okay.
This is Alyssa.
Hi, Alyssa.
Addison.
Addison.
Miley.
Miley. Okay.
This is Will. This is Weston. That's AJ.
What was it?
AJ.
AJ. It is. This is why we do this.
Yeah.
No, that's great. Okay, very cool. Thank you all for doing that. That's important. And now a quiz. No. Okay, so we're gonna start this class. We're not, like I said, we're not gonna dive into like systems of anatomy. We're not gonna be like, all right, the nervous system, there's a central and there's a parasympathetic and a parasympathetic and whatever. We're not gonna do that. We're gonna start giving you guys what I consider to be the most important thing, which is like a foundation in like the biodiversity. Because a lot of times anatomy classes go zoom right in, and half the stuff you talk about is about people, snooze. There's cool things people have, great brain, weirdo back, but otherwise, no, let's talk about some weird shark that has the same kind of stuff, and we can talk about the same thing. But to do that, you guys have to have some level of understanding of the diversity of the vertebrate life on this planet. So we're gonna cover it, but if you're taking notes, a vertebrate is any animal that has a skeletonized backbone. A vertebra is one bone, vertebrae is plural. You don't break your vertebrae unless there's like a bunch of stuff going on. you have a disc between your vertebrae, you have one vertebra each. Anyway, all things like that, those are vertebrate animals. And so vertebrates are animals, they fit onto the rest of animal life. There are some things that you guys probably think of as invertebrates, animals without backbones. We're gonna talk about why that's a terrible classification system, because like everything is an invertebrate that isn't a vertebrate. And some of those things are our cousins, much more closely than others. So we're gonna get into that. But before we go too big, let's just start with today's biodiversity of backboned animals that are alive right now on this planet. There are almost 69,000 species of vertebrates. That is a number that in the last 20 years or so has kind of gone like this a little bit, because we have really, really good molecular systematics. We can go out into the rainforest and catch a bunch of frogs and sequence their DNA and be like, these frogs look pretty similar, but there's 4 populations that are actually diverged from each other for 3 million years now, and there's 4 kinds of frogs, not 1. So a lot of the diversity of life on Earth is kind of increasing. We are constantly learning about new species, and that's not really in quotes. Sometimes we knew about the animal as a thing you can hold in your hand or something you can catch with your net for a long time, but now we're really starting to pin down for vertebrates the actual count of species. You can imagine what a nightmare it is for things like beetles, or ants, or whatever, or there's hundreds of thousands of kinds of beetles. There's 300,000 kinds of beetles. There's only 68,000 some vertebrates total, right? So vertebrates are very well studied because we care about vertebrates, because we are vertebrates. This is a little color-coded pie chart of that relative number of species in each of the big groups. These are big units of biodiversity that you guys are going to learn very well. And there's the little key over there on the side. Some of those words, I'm sure you're like, sharks. Other ones you're like, I don't know what that is. And that's what we're going to do throughout this class. So just to give you guys that breakdown a little bit, all the ones that are starred over there are the ones that have enough species to even show up on this pie chart. The other ones are not very speciose, is the word. So there's about 1,150 kinds of sharks, stingrays, things like that. That's a lot, 1,000 some kinds of sharks. The gigantic, almost 48% or whatever it is of vertebrate diversity are bony, ray fin fishes. So if this class was proportional, we would spend 2 months on fish. We're not going to do that, but that would be fair. So bony, ray fin fishes, we're going to talk a lot about that. That green group are frogs, so not amphibians, just frogs, 6,400 kinds of frogs and toads, things like that in the world. About 660 salamanders, so the things that look like lizards, but they're kind of slimy. They are also amphibians. What's the deal? Some of you probably don't know about these. There's about 250 caecilians, which are limbless, living in the wet leaves of the rainforest amphibians. They look like a little snake or a worm. They are an amphibian. They have lost their legs, but they are like a snake in a lot of ways. We'll talk about them. There's you. We have a very precise number of how many mammals there are. I didn't round to the tens place or the hundreds place because everybody cares about mammals so much. So that's last year's number. It might be different now, but 6,495 mammals. The jackrabbit is our logo for today. That's mammal diversity on the rest of vertebrates. 10,000 plus, probably higher than that by now, kinds of squamates. So that's things like snakes and lizards. A lot of snakes and lizards on this planet at species level. That little thin green piece is turtles. About 340 kinds of turtles in the world. And then who's missing? Yes, but also there's about 10,000, almost 11,000. It's actually getting close to 11, but nobody says 11 yet because you want to really hit that number correctly, and it's not actually quite there yet. 10,800 or so species of living birds on this planet. So these are the ones with stars. If it has a star, sharks and rays, ray-finned fishes, frogs, it's on this big pie chart to give you some idea of the relative number of species of the different groups of vertebrates. Here are all the rest of them that don't have a star. If you don't know what those are, don't worry. I'll make sure you definitely do know what they are. But there's some jawless fishes, hagfish at the top, and then animals called lampreys. There's some fish, there are 50 species of these things called ratfish. They're cartilaginous fish like sharks, but they're absolutely not sharks. There's the fishes that are closer to us, land-living vertebrates. They have lobed, fleshy fins. There's 2 kinds of coelacanth and 6 kinds of lungfish. There's this weirdo thing that looks like a lizard, and it is the sister to lizards, and it looks just like a lizard. The only problem is that it's all by itself, just like the Watson, just like the aardvark. And it has a lineage that goes back almost 250 million years, and there's only one left, and it only lives on a couple of islands near New Zealand. So it's its own thing completely, even though if you saw it, you'd be like, what's it? And then, yes, there are 27 kinds of crocs and alligators. Not very speciose crocs and alligators. So here's a nice little vignette of all those things. All those groups on the left there total to about 0.3% of the species level diversity of Earth. So if you added up all those numbers, like there's more kinds of butterfly fish in the world than there are all of those things put together. So there's differences we can talk about here, but those animals are super, super, super important. We should be very glad that they're alive still, because we can study so much about evolution and vertebrate anatomy by having them be organisms that are able to be studied. So here's a nice little overarching super duper view focused on biodiversity and the biggest groups. Obviously mammals, you guys know mammals super well, whether you realize it or not. And so whales and bats and kangaroos and platypuses are all here in the room. So there's a lot going on in each one of these colors. Go ahead and for yourself, take a few minutes and think about these two, please. So now if you feel like you have an observation or two, or hopefully a question, talk to your neighbor that you just introduced yourself with. And what were your observations? What are your questions?
They separate a kangaroo fire.
Any groups want to share something that you're talking about or a question you have or anything? There's none. Just so you guys know, the next Tuesday, Thursday, and I guess Monday afternoons for until April, there's gonna be a lot of like this kind of stuff. So it's not right answers, I'm not fishing for things, you can come back on. Usually I just want to know like what you're feeling, what you're thinking. Yeah, what were you gonna say, Dave?
One question, or like one observation that we talked about is that things that live in water tend to be more diverse.
Okay, so what are you basing that on?
So like there's 32,000 kinds of braided fish problem.
Yeah.
That's nearly half of all species.
Anybody have any comments or thoughts about that? Yeah, that's
Well, the ocean makes up the majority of the planet's surface, and there's a lot of space for a lot of species in there.
You want to know something freaky? 32,000 species of ray fin fishes. It's a little bit less. It's like 4951. Almost half of that blue are lakes and rivers. And the other half is the ocean, which is 70% of the surface of the planet. So you guys are biologists. Lakes and rivers as a volume of habitat on this planet are like so small. But why why would there be so very many species in lakes and oceans, lakes and rivers compared to oceans? You can think about that percolate. Why does every river have its own this subset of catfish? Why does every lake have its own? Not every lake system. Just something to think about. So half of this diversity that's blue here is freshwater almost. So totally inverse to what you're saying, but you're right, of course. Yeah, go ahead.
So kind of observation and question combined that I have.
Love it.
Is it's interesting to me that all of the mammals are grouped together, including like marsupials and stuff.
Yeah.
While crocodilians and lizards are separated.
Oh,
So like, why are they separated while like a kangaroo and humans are the same?
anybody have any thoughts, ideas? We'll get there, of course. You'll know the answer soon, but anybody else? Yeah.
I have an observation that goes along with that.
Yeah.
That, like mammals versus like the lizards and the snakes, body type diversity,
Ooh.
like mammals look really different, like a human versus a rabbit.
Day one, we're going for it.
The anatomy looks different, but, or the anatomy is like the same, but visually very different versus like lizards.
Okay, and somebody else try to put into words. They look different. There's a lot of different kinds of body things happening for mammals versus whatever. What did you say, lizards or something? Yeah. What's being talked about up there? So like an iguana, and a Komodo dragon, and a chameleon, and a skink, or whatever. You guys are all like, what do they look like? You picture them. They're scaly. They look like this. How about a whale and a bat and a possum and a dude? So mammals maybe have higher morphological disparity, which means differences in the shapes. There's a ton of these things. There's a ton of birds. One of the things that's so cool about birds that we're going to get at and why some of these things are split up and some aren't, there is no chance. Maybe there's 2 in the world. There might be 2. Other than that, there's almost no chance I could show you guys a bird you've never seen, and you'd be like, is that something else? You're going to know it's a bird. There's certain sort of gestalt things that are like, for sure. They're kiwis. I'm thinking about kiwis. You know, kiwis are, they look like mammals from the back. Anyway, most birds though look like birds. Most frogs look like frogs, although some of them definitely don't, and I'll show them soon. Fishes get crazy, mammals get crazy. Squamates can get crazy, but like a snake's a snake. There's a lot of cool stuff with snakes, but you guys are always do that. I'm gonna show you a bunch of things that look like snakes that aren't snakes, but a snake looks like a snake. So, okay, these are great ideas. You guys have already brought up questions of species diversity, biogeography a little bit, habitat, questions of my nesting. How come how come platypus isn't over here and then marsupials is like this and placental mammals is like that? I chose to make mammals just brown. You'll learn why. There's a reason. So just a quick answer to your question though, lizards and crocs, their divergence from each other was hundreds of millions of years ago. Our divergence from kangaroos is like less than half of that time. So it depends what you care about. You're right, of course, that I could have. And you guys have no idea what could have happened, really, if I had done anything with this. I took the easiest possible way out. Otherwise, there would be like 7 or 8 huge blocks, and then this would be like 6 columns. So I was like, nope. Okay, that's great. I just wanted to get you all thinking. And what we're going to do now is kind of move through into your prior knowledge. So if you've never been told this before, I think it's really important for you to know. People learn really well, like your mom remembers a thing she heard or something that happened on Jeopardy. People learn really well if they have a thing in their head already that they get to build off of, instead of just like a bunch of new stuff. So that's called prior knowledge. If I was teaching a fungus class or entomology, and we were doing the same thing with insects and all different kinds of insects, and like most of them are bees and ants, but here's a couple weirdos. You guys maybe you do, but maybe probably you don't have as much just back of your head, you've been alive for as long as you've been alive, knowledge about vertebrates than you do about like bugs. You guys know a lot about vertebrates because you care. You were a kid, you probably had plastic versions of a bunch of stuff. You have a lot of prior knowledge. People know about vertebrates. So please, I gave you 2 totally generic pictures of like Earth with nothing in them, animal-wise. There's definitely organisms in both those pictures. But no vertebrates are in these 2 pictures. They're just to get your brains cooking. If you want to think of a big sand dune or a city, that's fine too. Just some images, you can use them or not, on your own completely. This is going to take like 10 minutes or more. On your own completely, try to write down 10 species that you would put into these 5 categories. You're gonna write down 50 animals right now. It's gonna take a minute. So give me 10 birds, give me 10 fish, give me 10 mammals, this is gonna be fun. Give me 10 amphibians, give me 10 reptiles. I just showed you that there's like 8,000 amphibians, so you can do it. So we're gonna take our time here. Go ahead.
You want specific species?
I know that that's not really realistic, and I don't really need you to be like the Yellowstone cut trout, spotted trout, like, you say, now no one can write this. You say red throat trout or red band trout, great, I'm fine with it. Get as specific as you need. This is about what you already have in your head. It's not a test, it's not an assessment. While you're thinking, I want to say out loud that if you're sitting there being like, oh my God, I don't remember what an amphibian actually is, that's cool, that's fine. What is reptile again? I don't remember exactly if that counts as not, that's fine. You're not supposed to know all this already necessarily. Everybody still going strong? Anybody hitting a wall? The enticement of Google, so close. Okay, I'm gonna interrupt you wherever you are. It's okay if you don't have 10. Go ahead and talk to your neighbors for a second. How was this? Share what you got. Which ones were really easy? Which ones were really hard? You feel like, so we have less time than I currently did. Less time than I thought we did, so I'm gonna interrupt the flow I was hoping to build, but that's okay. Which category was easy? You guys feel like as a group, you were like, that one was like, yeah, I got it done. Mammals. Then both of which, I get a 10. All right, mammals are easy, that's fine. Which, anyone, do you have agreement with what's difficult, or which 2 or 3 were difficult? Or which is the hard one? Where now, but the other, we're like fish and bird. Fish is easy. There's differences. All right, I want to get a little bit of meat up here on the board. So I was gonna have you guys come up. I don't think there's enough time. I'll do the color coding. Each group, give me like pick 4 or 5 from. Well, how about this? Just people write like where everybody wrote a horse or something like that. Anything like that, one time that you all, maybe you don't have time to share all 50 of the things, but I'm curious. I didn't even write first. Wow.
So basically.
All right, there ain't no community rhyme or reason to this. We've sent them up here on the board, so I'm just gonna go around each group. I'm gonna ask you 5 of your reptiles. Go ahead, you can go ahead and go around, give me 5 reptiles. King Cobra. King Cobra. The first time we're gonna do this whole semester, what a baller start. This is how we're gonna run it every time. King Cobra's genus is like a city of Vegas, which means the same. Okay, King Cobra, next. Bearded dragon, anybody have one? Go ahead, keep going.
But not.
No, 5 from you guys, 3 more. Oh. Well, or can I get it?
Iguana.
Iguana. 2 more from you guys.
American alligator.
Ooh, I'm just gonna write alligator. Okay. Skink. Skink, ooh. Like 1,200 skinks. All right, you guys, 5.
Black mamba.
Black mamba, another nightmare snake. Okay.
Rattlesnake.
Rattlesnake. Keep going.
Komodo dragon.
Komodo. Go ahead.
He restricted.
Oh, constrictor.
Oh,
Boa constrictor. Yeah, it is restricted to some places. Okay, boa constrictor. What else? One more. Anaconda. Another kind of boa. All these names. All right.
corn snake.
Corn snake.
Hognose snake.
Hognose snake. You don't know hognose snake, you're gonna love it.
Chameleon.
Chameleon. What I'm hoping happens here is that eventually someone's gonna say one and agree. Oh, we should have thought that. Okay, one. Here we go. Ooh, that's a big defense one. Okay. One more. Cayman. All right, keep going.
It's not already.
Now we're getting another moment when I want to hit. So is there anything that's left to say?
That rattlesnake, I don't think it's.
Yeah. And you guys have any? Yeah.
Oh, yeah. Gila monster.
Gila monster.
Horny toad.
Yeah. Who's seen a Romagola? They live right here in town.
Blue racer snake.
Okay.
And that turtle.
Thank you. None of you have said a turtle this whole time. I was about to be like, sea turtle, anybody? All right, we're done. Give me your bird. We'll start with you guys now. Give me 5 birds.
Pheasant.
Pheasant.
Partridge.
Oh, gosh. Okay.
Hungarian bird.
Well, no, but okay, shall you say chucker? Okay, all birds you can shoot in Idaho. Keep going.
Guinea fowl.
Guinea fowl.
Peacock.
Yeah. Okay, thank you. Next group.
Red robin.
All right, Rob. I feel like. That's good, Robin. Okay.
Fish.
Finch, yep, Robin, Finch,
Eagle.
Eagle,
Crow.
Crow,
Osprey.
Osprey. Thank you. Next group.
Grouse.
Sage grouse,
Kiwi.
kiwi, pelican,
Penguin.
penguin,
Pigeon.
and pigeon. That's a nice alliteration.
What's a piece?
Lots of peas. Yes, next.
Ostrich.
Ostrich, good one.
Bald eagle. Oh, yeah. California condor.
Ooh, I'm just gonna write the, I'm gonna make it here. Condor. Ooh, I'll write scarlet ibis. That's pretty perfect. Ibis. Emu. Emu. Toucan. Thank you. That's a good one. Hummingbird. Hummingbird. Okay. Raven. One more.
Magpie.
What'd you say? Magpie. Cool. That one I bet was sort of easy. Anything I'm missing? You guys are like, nobody said the my favorite one. Chicken. Great. Okay. But this is like such a time nightmare, but we should have done something. But that's okay. All right, starting over there, give me 5 fish. No, that's a squid. Is it cuttlefish? I'm sorry, I can't say cuttlefish. That's a squid thing.
Salmon?
Salmon.
Clownfish?
Clownfish, Nemo, thank you. Lionfish. Swordfish. How many nouns with fish can you think of? Because I bet there is one.
Goldfish?
What'd you say? Goldfish. All right, next. Beta. Rainbow fish. Won't accept rainbow fish. Give me another one. Tuna. Sea bass, which is not really a bass, but okay. Yes.
Pufferfish.
Pufferfish. Yeah, sure, we'll keep going. Arapaima. Who's got a mental picture in their head of Arapaima? Mike. Okay, go ahead. Arowana. Butterfly, which one? Butterfly loach. Car. Barracuda. All right,
Great white shark.
I'm gonna write the GWS.
Salmon shark,
Salmon shark.
black and white tip reef sharks,
All right, we got reef sharks. Yes.
nurse sharks,
Nurse shark,
and tiger sharks.
tiger shark.
Those are the sharks I thought.
How many of you guys are like, okay, so tiger goes here and lion goes here? Okay. Barramundi, who knows barramundi?
Dace?
Dace, yes.
Walleye?
Walleye. I like the Idaho fauna I'm getting. Okay.
Other side show?
Leather side chub? That's a little cutie. Leather side chub sounds a little intense, right? Okay. Stingray. All right, we'll take it. Mammal me. You guys did great on fish, that's all.
Elk? Moose?
Okay, wait, I'll just do it for you. You don't even have to say it.
Pardon me, the elk or
Moose, deer, antelope, bison. Okay, next. Okapi, excellent. Anybody know Okapi? You always can be Googling. What else? Polar bear.
Grizzly bear,
All right.
black bear,
Bears. Right. Elephants. Let's say.
Whale.
Whale. Whoa, that's a big category. All right. Mice, a bigger category. Goat. You mean like LeBron or you mean like a goat? Okay. What'd you say?
Giraffe.
Giraffe. Yes, great.
Bats.
Bats.
Cats.
Bats. Cats.
Rabbits.
Rats. Great. Okay, for you guys. Zebra. And, oh, I knew from okay. Dolphin. This is the first time I'm gonna do this, kind of, if we're gonna call this a thing, this goes under that. That's okay. Dolphin.
Rabbit.
Bunnies. People. We'll say humans for that. All right, you in the back. Moles. Moles. Anybody want to play on this train still? Moles. Moles. Okay, sorry, go ahead. Kangaroo. Kangaroo. Platypus, I'm gonna put because I heard it. Any others? Wolf. Wolf. Excellent. All right, I thought mammals would not be difficult. I'm guessing when I read all your favorite animals in a minute, and you give me your piece of paper, it's gonna be a lot of this. Because it always is. All right, best for last. You guys get this, go first.
After clawed frog.
Ooh, clawed frogs, aka xenopus, the lab animal. All right, what else?
Leopard frog.
Leopard frog. What else?
Dark frog?
I'm gonna say dark frog, but yeah, sure. Go ahead.
Bullfrog?
Bullfrog. Are you seeing how humans do things? Leopard shark, leopard frog, leopard. Very intense. Okay, what else? Axolotl. All right, next group. Oh, anything more specific? You don't have to be. You can just say.
I have like 30
Yeah, I
seconds.
went to salamanders.
Salamanders. There's a lot of them. Okay, keep going. What'd you say?
Geckos.
Geckos go over under red reptiles. It's kind of lizard. This one's supposed to be. All right, what else? We go to the next group.
Sicilians?
Well, there we go. Now we got them all. Sicilians, salamanders. Go ahead, keep going.
What house code?
That's one of our locals. A toad. Okay.
Hellbender?
Hellbender. That's a big, scary amphibian.
I have a lot of salamanders.
Okay, we'll move on then. Anybody? You have anything else to add? What?
Mud puppies.
Mud puppies. Mud puppies, yes. You said mud puppy and I thought of mud skipper, which is a fish that walk. But that's not what you're talking about. Okay.
It's a bunch of salamanders. I'm not sure if this is real or not, but I said cane toad.
Cane toad's real.
Okay.
We're almost out of time anyway, so I might as well tell you, I was walking once in Australia at nighttime, with a flashlight, like the biggest thing, but other things and everything, and a cane toad flew onto my, like, into my ankle, and I screamed and I jumped really high. Then I put my phone on and. Okay. Yeah, nice one.
Blue-tailed salamander.
Blue tail, okay, the salamander. Any like, okay, keep going. Tree frog, I'm gonna stop because of time, not because I don't wanna hear all your stuff, but it is funny how we care so much about things that get named. What I want you guys to try to do, as we were doing this, you're getting an idea. What we're gonna start with next, on Thursday, because we can't do it now because I messed up. How do we know what an amphibian is an amphibian, when's a mammal a mammal? What makes these things categories? Do they work as categories? Are they evolutionary informative? What is the deal? You know what this means, you know what this means, but in terms of biology, these words are crazy different in being helpful or being extremely unhelpful. And that's what we're gonna do on Thursday. Please pass your sheets all the way to that side. I'll collect them. Because we're out of here, right? It's 12:15. And if there's a fish or a thing that you have no idea what it is, I'll post it on Moodle. Moodle will be up this afternoon. I'll post it on Moodle if you actually care to be like, I'm gonna Google that thing. Like, you'll copy, that's a good one. I'll do a snake for everyone. This all. Yeah.
So I have an interview and start with the video on weekend.
Oh, wow.
I have to fly there to.
You have the breeders last time.
Yeah, I'll be free, like my interview's at 3:15, so I'll be free from 11 to.
I could have, for it's with their, we recorded, not gonna do the Zoom thing. But we can talk.
Okay.
You need to watch or there's a.
Okay, I don't care either,
Okay.
whatever seat is free.
Definitely be.
Yeah, so I'm like, I already have a flight there, so I
Yeah.
can't.
No, I drive. I get it.
Perfect, thank you.
Yeah.
So whatever seat is for you.
Yeah.
Great.
Maybe we'll do.
That's one of that.
Yes, yeah, I've been with you, know, good.
No worries. I just thought, break.
Yeah, no, good, get in there. Anytime you want.
Yeah, cool.
Go.
Probably gonna be in there a few hours today, a few hours Monday and Thursdays.
Okay, that's great. You haven't took an Amy or anything, right?
No, I haven't.
So because of this class and a couple of things, I'm in Thursday and Friday, so. Okay, so if other days, just, you can see me on it, like spending, like what you're doing. And then we'll make sure, because I think you probably are pretty good to go, but I especially just start, that's your. That's gonna be there first. Okay, awesome. Yeah, thanks for checking in.
Yeah, I'm just curious, because I'm like, I was gonna go Monday, but I was like, actually, I don't know if like Amy wants classes or like, you know.
Yeah, she should be there full time and should have classes there.
Okay.
Okay. I think if you're,
Let's get some.
as a rule, she's probably there. Very so, yeah.
And every other Wednesday I'll probably be there, because I don't have classes Wednesdays and Fridays.
Oh, great.
I end up amending up. A little bit, so.
How's Christmas?
It's really
Like
nice.
Christmas?
Oh, yeah. It'll be nice.
Or,
Pretty much, we got like 3 different like, you know, like rocker seats.
Oh.
Like one, like you just discuss, yeah, pretty much. So like we got one for everything, you know, like bouncing, rocking, swinging.
this one?
Spin. Yeah. Christmas is good, that's good. Yeah, and this, man, I'm already like really love this class.
Yeah, it's gonna be, I like to start classes like this. It's pretty fun. We'll get in there. Cool.
Well, thank you.
Yeah.